Some tractors outlived the companies that built them. Some are still running 60 years after their first shift. The question isn't why they're unkillable. It's what, specifically, refuses to let them die. Waterloo, Iowa, 1963. John Deere rolls out the new generation, a clean break from everything they'd built before. The 4020 sits at the center of it. 6 cylinders, 6.6 liters, 93 horsepower at the PTO, closed hydraulics, a transmission that actually worked. Over 9 years, Deere built 184,879 of them, 168,311 diesels. The machine landed straight into the corn and soybean belt and never left. The 4020 came with a choice: synchro range as standard or power shift for an extra $630. Most buyers took the simpler box. They were wrong. Synchro range wore quietly. The grinding showed up late and looked catastrophic when it finally did. Power shift failed earlier and louder, but cheaper. The mechanic with synchro range was splitting the rear end. The one with power shift was adjusting a lever. Hydraulics ran everything at once: steering, the 3-point hitch, the remote cylinders, 132 GPM pump, one shared fluid. When the O-rings in the distributor started weeping, all 3 systems slowed together. The real killer wasn't the pump. It was dirty fluid or a $3 seal no one had changed. Mechanics who understood that could put a 4020 back in the field in 40 minutes. The ones who didn't were ordering parts for the whole block. In 1972, Deere killed the line. 9 years, 184,000 machines, done. The price went up. The 4020 became the last simple big Deere, and farmers with one stopped treating it as equipment. They treated it as irreplaceable. Right behind it came the 3020, same factory, same 9-year run, different market. 4 cylinders, 62 horsepower at the PTO, same synchro range, but a 21 gallons per minute pump instead of 32. Deere's answer to the farmer who needed a 4020 but couldn't justify the cost. Over 100,000 units built. The transmission wore faster because the 3020 spent more time near its power ceiling. A 4-body plow on wet clay wasn't overwork. It was a Tuesday in October. The hydraulics hit their limit sooner when someone bolted a front loader on and tried to run the remotes at the same time. What kept the 3020 alive wasn't its engineering. It was parts compatibility. Nearly every seal, liner, and bearing that fit a 3020 also fit a 4020. One dealer shelf, one parts book, one mechanic who needed no retraining. When Deere stopped production in 1972, both machines entered the same second-hand market and held their value for the same reason. They were the last of Deere's simple era. Everything that followed cost more to fix. International Harvester understood this before anyone else. They just couldn't keep it. The Farmall M came out in 1939. 3-plow row crop, 4 cylinders, 34 horsepower at the drawbar, high clearance, 270,140 units over 13 years. The logic was pure field practicality. Minimum parts, maximum access. A farmer could diagnose most of what went wrong with it before calling anyone. IAH also built a diesel, the Farmall MD. Started on gasoline, warm it up, switch it over. The problem? The MD used a carburetor that fit nothing else in the Farmall line, an injection pump that needed specialist tools, and a reverse rotation distributor found on no other IH engine. 3 unique parts with no cross-compatibility. When anyone failed, you waited. The gasoline M didn't have that problem. Same carburetor, same ignition, same supplier across the whole line. The simpler machine outlived the advanced one. The M ran hot on long shifts without a thermostat. Operators paced it. What really cemented its legacy was a mistake made after it. IH carried the M's final drive forward into the 460 and 560 without redesigning it for the higher torque those engines produced. In June 1959, IH recalled every 460, 560, and 660 already in the field. The M wasn't responsible, but farmers who'd run one for 15 years without a failure made the comparison loud and clear. The Farmall H ran beside the M on the same farms, doing different work. 2-plow rating, 24 horsepower, no power steering, almost no hydraulics. Built for orchards, tobacco fields, cotton rows, tight spaces, shallow passes. On heavy ground, it hit its ceiling fast. 2 plow bodies on wet clay meant 1 plow body in practice. 8 hours of unassisted steering on compacted soil wore out the operator before the machine. Frame brackets at the rear axle cracked when someone hooked a trailer too heavy for the class and just kept going. None of that stopped it. The H carried no hydraulics, which looked like a limitation until the early 1950s, when competing brands were losing hydraulic systems to cold starts, heat leaks, and contamination. The H had none of those failures. Nothing to leak, nothing to freeze, nothing to replace. It also shared pistons, bearings, and seals with the M. Same shelf, same mechanic, same afternoon. 2 machines, 1 parts order, 1 toolbox. That combination kept both running on farms long after newer equipment arrived and broke down waiting for a specialist. By 1963, International Harvester had a problem that money couldn't fix. 4 years earlier, the company had recalled every 460, 560, and 660 already in customers' hands. Final drives failing under loads those axles were never designed to carry. Dealers billed IH for 19 hours of labor per machine. Most finished in 12. It was profitable for everyone, except IH's reputation. The 806 was the answer. 6 cylinders, 361 cubic inches, 95 horsepower, and, most importantly, final drives built for the engine they were actually bolted to. IH had learned the lesson in the most expensive way possible, and the 806 made sure it showed. 2 things still followed it from the old architecture. The torque amplifier, a planetary reducer that doubled pulling torque without stopping, worked with the right fluid and regular service. Without either, the friction discs started slipping under load. Quiet at first, progressive, then gone. Replacing them, 4 to 6 hours in a shop, not a field repair. The hydraulics ran on O-rings that IH never fully resolved. Seals in the pump block and distributor deformed with heat or wrong fluid and started bleeding pressure internally. The hitch slowed, the remotes drifted. The repair was cheap, but only if the mechanic went for the seals first instead of the pump. Most didn't. Farmers who bought an 806 after living through the 560 recall were already suspicious. The machine had to prove itself twice. When it held, and the final drives held, the loyalty it built was harder than most. The 1066 arrived in 1971 with one fundamental change: a turbocharger. DT414, 6.8 liters, over 100 horsepower at the PTO. First IH model, where turbo was standard, not an option. 54,947 units in 5 years. Aimed squarely at grain farms, pushing 500 acres that needed a machine to keep pace. The turbo added 20 horsepower and introduced a failure mode field mechanics hadn't seen at scale: seal leak in the turbine, oil into the intake, blue smoke, rising consumption. The bigger problem was shutdown. A turbo needs time to cool after hard work. Operators used to older engines killed the ignition the moment they stopped. At 600 to 800 hours, the bearings showed it. IEH published turbo operation guidelines to dealers in the first 2 years. Machines that followed them hit 5,000 to 6,000 hours before a rebuild. The ones that didn't were in the shop at 1,500. IIH sold its tractor division in 1984. Case IIH kept the parts catalog. The 1066 was already outliving its own manufacturer. Ford built 524,000 units of the 8N in 5 years. No other American tractor model matched that in the same window. It arrived in 1947, at the exact moment small Midwest and Northeast farms were making the switch from horses. Cheap enough for a single operator, simple enough that the same operator could fix it. It also arrived carrying a lawsuit. Harry Ferguson sued Ford for $340 million after their handshake agreement collapsed. Some of the 8N's engineering decisions exist not because they were optimal for the field, but because Ford needed to route around Ferguson's patents. The front-mounted distributor on early models was one consequence, and a bad one. Moisture got between the cap and housing, and the spark went sideways instead of to the plug. The engine wouldn't start with no explanation obvious to anyone who hadn't seen it before. Ford moved the distributor to the side in 1950. The first 3 years of production carried all the failures. In 1952, Ford settled with Ferguson for $9.25 million, roughly the cost of 12,000 new tractors. The 8N's 119 cubic inch engine rarely worked hard. Most of what farmers used it for, cultivation, light hauling, mowing, ran it at 60 to 70% capacity. Lower heat, lower wear, longer life than the numbers suggested. The 860 replaced it in 1954. New engine, the Red Tiger, 172 cubic inches, 36 to 40 horsepower. Same basic architecture, same repairability logic, 3 years of production. The Red Tiger had one consistent failure. The head gasket between the second and third cylinders gave out under extended heavy load, not on light work, on long days pushing a full plow through tight soil. The engine ran unevenly after that. Mechanics who'd worked on the 8N already knew the Ford Ferguson hydraulics well enough to service the 860 without retraining. Parts overlapped. The transition cost dealers nothing. The Ford 5000 ran from 1965 to 1976. Diesel, 3.8 liters, 65 to 70 horsepower, 8-speed gearbox, and an optional transmission called Select O-Speed that could shift all 10 ratios without a clutch pedal. Select O-Speed was technically ahead of its time. Operationally, it was a liability. The clutch packs in each ratio wore fast under load shifting. It needed a specific fluid, Hay-Tran, and nothing else. Standard ATF, or engine oil, started dissolving the pack friction within a season. Rebuilding Select O-Speed meant a full teardown. Shop work, not field work, and priced accordingly. The 5000 with the standard 8-speed had none of those problems. By the mid-70s, every Ford dealer in the network had learned the same 3 rules. Never substitute the fluid, replace the rear crankshaft seal with the clutch, check the power steering pump before the busy season. That accumulated knowledge inside the dealer network kept the 5000 running long after production ended. Oliver never had the dealer density of John Deere or the brand recognition of International Harvester, third or fourth choice for most American farmers in the mid-60s. That position forced something useful. Every machine had to justify itself on merit because the salesman wasn't going to do it. The 1650 was the result. 6 cylinders, 60 to 70 horsepower, open center hydraulics, and a live PTO shaft that ran directly from the flywheel. That last detail mattered more than the spec sheet suggested. The operator could stop the tractor without stopping the baler or the mower behind it. Deere and IH had that feature on larger machines. On the 1650, it came standard, at a price that didn't require a co-op loan. The gasoline version had one recurring problem: the shared intake and exhaust manifold gasket. It leaked on cold starts, ran fine once warm, and nobody touched it. Ignored long enough, it accelerated valve wear and cylinder deposits. Not a catastrophic failure, a slow one. The fix was 3 to 4 hours without special tools. The tractors that got it done on schedule ran for decades. What the 1650 never had was a dense parts network in Deere country. In areas where the nearest Oliver dealer was 2 counties over, a worn seal could mean 2 weeks of downtime. Technically sound machine, practically stranded. The ones that survived were on farms that either had a loyal Oliver dealer nearby or an owner who kept a parts shelf stocked in advance. Oliver was absorbed by White Motor Corporation in the late 60s. The brand faded, the machines didn't. The 1850 was the top of the line, and the most complicated thing Oliver built in that era. The standard version used a 6-cylinder Waukesha Oliver diesel. The optional engine was a GM 371, a 2-stroke, 3-cylinder Detroit diesel, where ports replaced valves and a supercharger pushed air through the block at all times. Around 90 horsepower, distinctive sound, and a completely different internal logic from everything else on the market. Mechanics who knew IH or Deere had to relearn from scratch. In areas with a strong Detroit diesel service presence, the 371 ran almost indefinitely. Everywhere else, it isolated the machine from the people who might otherwise fix it. The hydraulic pump sat inside a housing shared with the transmission. When the seals failed, and they did, hydraulic oil migrated directly into the gearbox. The symptom was obvious if anyone was checking: hydraulic level dropping, transmission level climbing. Mechanics who caught it early paid for seals. Those who didn't paid for gears. The optional hydropower gave 2 extra ratios without declutching: useful under load, destructive when engaged wrong. The discs wore fast. Rebuilding them meant partial transmission disassembly, not an afternoon in the field. The 1850 without hydropower, with the standard mechanical gearbox, was the most reliable configuration Oliver made. Most buyers who learned it the hard way. The Case 930 was built around one principle: pull harder, rev less. The A401 diesel, 401 cubic inches, 6 cylinders, roughly 100 horsepower, peaked between 1,600 and 1,800 revolutions per minute. Most competitors of that era pushed to 2,200 or beyond. The 930 didn't need to. Long stroke, large wet sleeve liners that could be pulled and replaced in the field without removing the engine, and a front axle heavy enough to hold its ground under a full 4-body plow. The optional Case-O-Matic drive, a torque converter between the engine and transmission, was where it got complicated. Right fluid, regular intervals, it multiplied torque cleanly. Wrong fluid or one skipped service and the converter consumed itself from the inside without warning. Farmers who passed on the option and took the direct mechanical drive had a machine with nothing unfamiliar to diagnose or fail. The Case 730 ran the same principle at smaller scale: 4 or 6 cylinders, gasoline or diesel, the same unhurried engine architecture. LP gas versions were common in areas where propane undercut diesel prices, reliable combustion, but the carburetor needed calibration that neither gas nor diesel operators thought to put on a regular schedule. The diesel 730 shared its service logic almost entirely with the 930. Same wet sleeve liners, same access points, same basic repair sequence. In a mixed case fleet, one parts inventory covered both machines. Farms that ran a 930 already had everything needed to keep a 730 in the field. Alice Chalmers built the WD-45 from 1953 to 1957 and shipped it with 2 things competitors hadn't offered yet: power adjust wheels that slid on a splined axle to change row spacing without dismounting the tire, and a traction booster that transferred weight hydraulically onto the rear axle under draft load. Both solved actual field problems, not showroom ones. The gasoline version's carburetor needed consistent calibration. Left alone, it ran rich, fouled the plugs, and shed power gradually enough that operators blamed the load before they blamed the mixture. The WD-45D diesel was more efficient, but carried an injection pump with no cross-compatibility in the AC line. Outside AC dealer territory, the right parts took time to arrive. The D17 replaced the WD-45 in 1957 and ran for 10 years across 4 production series. Each series corrected what the previous one had gotten wrong: power steering pump failures on Series 1 and 2, fuel system issues through Series 3. By Series 4, AC had a machine that didn't need a caveat attached to the sale. The traction booster carried forward unchanged and kept working. What the D17 had that the WD-45 never got was time. A decade of corrections built into the same basic frame. Later series machines don't repeat the failure patterns of the early ones. 4 revisions, 10 years, 1 chassis. That's why D17S from the mid-60s still turn up doing actual field work today.